Hi, in this webinar we are going to show the workflow between advanced design and advanced design connection. So advanced design is our structural software, and advanced design connection is being rebranded from Grytec and is a product of Idea Statica. What we are going to show is creating a model in advanced design and then export one of the connection to advanced design connection to design it, and this is below. You can see the goal of this webinar. The schedule is a quick overview of the two software, and then there will be the live demonstration, and then I will just tell you a couple of information. So if you need trials, if you want to send us questions as well, and then I will answer just a couple of questions. So as I said, Advanced Design is our structural software for the finite element analysis. I will quickly go through the different kind of features that Advanced Design has, and you can do the design for concrete, timber, and steel, and optimization as well. As you will see in the next webinar, we are working to show the workflow between advanced design and other software, for example Revit and Advanced Steel, as well as Advanced Design Connection. Advanced Design Connection is a software developed by Idea Statica and concentrated on steel connection. You can create as well simple or more complex connection, and it will work in more than one direction. So the main features are reported here. Those are stress strain analysis, but then going through the backlink analysis, stiffness, etc. So I'll go now through our the creation of the model in Advanced Design, and then export one of the connection to Advanced Design connection. So the first things to do is creating a couple of subsystems. So I set a level for the column. I don't know how much familiar are you with Advanced Design, and then I create a couple of elements. So for example, I can copy them, just holding Control and then drag the element. So I create my column, and then I create another subsystem for the beams. This will allow you the creation of subsystem to select and amend the characteristic of your element, and also to design better. So for example, I can select all the elements just by pressing the spacebar on the subsystem. Then I can use my copy tool to select the vector and say I copy it 3 times, and then I will draw as well the beam in the other direction. So now I will select them. I will change the direction and the section of the beam. So now they are the UKB instead of UK column. Okay, once I've done this, I create our support, and then I select all my column, right click, and I create the support on them. I can then select all my support and drag them into the correct subsystem. Okay, then I create load areas. Here we go. This allows me to create then area loads on the top of it, and then I can copy my structure. And I create also some bracing, so, and then my structure will be complete just by inserting some loads. So I click on them. This is to show you then that in advanced design connection you will recognize also the different angles that you set in your project. So I just select them and I can copy them holding Control, and then I reselect all of them and just create other bracing. So this is my structure, just simple one. I select my load area and I create some loads on the top of it. So -5 for example. Here we go. So now I have my structure. I run the I create the combination. In this case I create just a simple one from the Eurocodes, the simplified one, sorry. And here we go. We are going to see a couple of results. So this will be the combination I will use the other software. So as you can see, we have I forgot to set that the bracing are just taking the load in the as axial. Really with axial with the releases, so pin the element, and so they're taking axial loads. So then I will look up at the forces. Here we go. So we remember this these forces. Then when we export this connection to advanced design connection, if you select the element, then we are going also to look up at the forces in the bracing. So 0.1 is just a few. Anyway, to export it, we go to BIM section of advanced design. Here there are also different kind of export also to Revit and advanced steel, but in this case we are going to advanced design connection. So clicking on it, it will ask you to export the correct section, and then here as you can see, you can design through the Eurocode or the American code. And if I click next, I will go to the mapping of my element. So I select it, and here we go. This one is one of my beam. So you can see it's quite handy to control. And this is my last one, the bracing. There is a question. So the question is why we set it in advanced design and is not fully recognized. I recognize all the European profile as Ideastatica is an European company, but they do release new. They do set new releases twice a year usually, and this will be implemented soon. So if it's not in the next in the releases that they have just released, it will be in the next one anyway. It recognized for the moment the European profile. Here there are the load cases set in advanced design, and then if you go to next, we can see all the combination. You can also create new ones, but in this case we are just creating the one from advanced design. Then we run our model, and as you will see, it will recognize all the inclination and the angle we have set. So if we go to the geometry, as you can see, this is my element, this is my column, this is the bracing, and as you can see there, the rotation and I have set, and here I have my two beams with two different rotation. So as you can see, this is the rotation, the difference rotation in X, Y, and Z axis. So here we saw all of them. And you can also set the rotation from for this alpha rotation. Okay, good. Though we go to the loads, we can already see them here, but we go through that. So this is as we can see, these are the load we have seen in advanced design, and this is for example the forces in my bracing. Then we go to the design. The first tool we see is the cut. The cut allows us to set the distance and to set the length of the element to draw our structure in a better way. So I'll show you quickly in this example. The column I want that is going to the until the top of the beam. So I just say further, and now I'm on the top of it, and I just set an offset. I can set, for example, an offset. To watch your structure better is important to go through the different kind of views, and in this case, as you can see, I set my structure with my offset, and then we go through the creation of a end plate. Quickly one. In this case, I want it to, for the element, for this beam, connected to the element, to the column that is here. You have the thickness, you can set bolt or weld connection, and you can set symmetrical to profile, or for example rectangle symmetrical, in which case you need to set the height and the dimension on the two sides, and then you can set also the dimension of the two welds. You can change the material just for the welds. You can create your own material. I will show you later on. I can just set, and here we create our bolts. So for example 40, 80, say 90, and 40 as well. No, say 50. So now if we go through my view, we can see it proper way. If we click on that and we see transparent, we see our view. So now I have set my bolts, and I can just create for the other a cut. So in this case, I come back to the solid version and I set it for my other beam. So is the member 230147. Look into the column, and as you can see, is already set. You can set the welds both sides, one side, none of them, as you wish. So it's quite handy to control. And I have already created this. And then the last one, we create our gusset. So we say that is for the bracing. We say that is a new plate. We are gonna connect it, and this plate will be connected to the column as well as to the other member. Now just by changing the depth of it, we will see it. Here we go. So we can say 350, and here is my gusset plate. If you go to the editor, you can also set different kind of chamber, arch, etc. The same is here. If we go to editor, we can also change the place of the bolts as well, and of the on the plate as well. We just come back to the geometry and set a length a little bit more for this element. So let's say 700. And if we go to the design, I just create it a little bit better. Here we go. So now I create my connection, and we are gonna run through the check. I show you here. Here you can set up all the different bolts. You have your library here, but you send also manually manually materials and strength, resistance, etc. The same for the steel. In this case, in advanced design, you don't have lambda and C, but you can set up the same material here, and then now that we have this, everything is fine. So the recognition of the material as well is something that will be quickly developed in the next release anyway. And the same for the section. You can also create a different kind of section, your own one, and you have different kind of parameters. So now that we have set everything, we calculate it. And it will go through that. I forgot to delete all the connection. I just to run it quickly, I just delete some of them, so we just keep 2 of them, and then I run the check, so it's a little bit more quick to show. If it says 100%, means that is the calculation is going well and is finding by iteration the results. If it is going to 0%, means that something is not working properly. Can be an instability, can be that you miss to weld your section, and so one element is not connected to the other. So now the analysis has been run, 100% of this, and of both of them. Now we see the plate resistance. As you can see now in this example, SNB's the stress are quite small. So the only plate that has really a lot of some strength on it is this one. But you can you can see the mapping of it, and as you can see, this in this area you can see the mapping, but then you can go through the different kind of calculation as well, and through the result as well. What is checking is that the plastic resistance of the plate is no more than 0.5%. So as for Eurocodes, we're going through the bolt. Here there's quite a detailed check of the bolt. You can go through all these parameters, and it's really useful when something is wrong, as you can see where exactly your issue is, and change the parameter or materials, or just the spacing of the bolt, or adding more bolts as well. The same is for the weld. These are all the check from Eurocodes. It does also base plate, so then you will have also the connection between your steel element and the concrete one, with the connection with the bolt is following the iota. And then another feature is the buckling shape. In this case we don't have issues, as you can see, but just to showing you the buckling shape. For example, the next issue is here, so if you have, for example, a buckling issue, in this case you can add the stiffness as well, and this will sort out all your buckling issues. Another nice tool is if you go to the Deformed Shape, and if we set a little bit more, we can see how it's deforming, and we can set, for example, stiffness or something else, just to make sure that our connection is working in the way we want. Okay, so here in this area, as I said, you can set, in this case, straight and buckling resistance, but you can go through also the stiffness. I will show you an example in a second. Capacity design, joint design resistance, for example, in seismic is really useful as well. And we go through the report, and now is creating it, and I will show you in this moment what I created in a preview one. So as you can see, this is more or less the same connection, and I run the stiffness module, and as you can see, for this element, that is the connection between this bin and the column, is telling you that is semi-rigid. So then if you want it pinned, or if you want it rigid, you maybe want to change and to add or remove bolts, or if obviously the connection is correct, and optimize it as you wish. Or if you or you can also take the rotational stiffness and set it in advanced design, as you can set elastic releases as well. So this is in here. For example, I just copied it and create a new case. That is something you can do. If you copy, you can it will copy the same project, and you can also change something and make and compare the results between two different projects. So if I go here and I change something, I add bolts, etc., it won't when I go to the number 2, it will just go back to my previous one, and I can compare the results. Hopefully the report has been done. So yeah, this is an example of the report. You have different ones, and you can set different kind of report. You can export it obviously in Word, Excel, etc. This is you can save images as well and set it in the report. So this is just the automatic one. So it's nice and clear. And yeah, this is all for this webinar. I'll go through now through my presentation, and here there are all the tutorial references for the two software and also the upcoming webinars. So as you can see, there is the webinar looking at the workflow between Advanced Design and the other software as well. So this is our tutorial for Advanced Design and the references to the lot of projects, so you can see what you can draw and which kind of structure you can deal with our product. And this is the tutorial. This is the website from Idea Static. Contact. You can send an email to me if you want any trial or if you have any question. And if you need any other information about packages, prices for both software, you can send them an email to Tom, that is my colleague. These are the other services that Grytec does. And if you have any question, so yes, I can come back to my to the tutorial as well to show you. Any question, you can send me an email, and I can also forward you the recording as well. So here we go.